we are towards the end of the chapter. Obviously, I'm skipping the optical instruments, that microscope and telescope for now. But we'll talk about this last instrument, and this is called prism. I will only make, so do you know how the prism looks like? I will only make a 3D diagram for now, but then afterwards I will only stick to a triangle. Okay? The diagram looks like this. Can you imagine? Later on we will stick to only one triangle, and that will represent the 2D projection of the 3D surface. What is so special about this prism? What have you studied about prism? What one thing related to light have you studied about prism? Dispersion. You may have studied dispersion, no? Dispersion is not so, it's not only, it doesn't only involve prism, actually it also occurs in lenses, but we do not talk about that there. But for dispersion, one important thing is deviation. If your ray is going like this, if it enters like this, then it suffers some deviation and comes out with some other angle, in some other direction. So that will be important to us later. So let's talk about deviation first. Deviation. I will make one diagram which will keep coming back to every time. So the diagram is something like this. I am making a triangle now. This is my prism basically. It has some angle A. I will call this angle to be the angle of prism, or the refracting angle of prism. Refracting angle. Let's say the incident ray comes off like this. Say it comes like this. This is my normal. What is this angle? Let's call it angle I. Angle I. That's the angle of incidence. After refraction, what will happen? So let's assume that outside is air, then what will happen? Towards the normal. No? Goes like this. It will suffer another refraction, and then where will it bend? Away from the normal. Actually like this. Can you imagine? Acha, let me call these angles. Let me call these angles R1 and this called R2. All the angles inside the prism, let me call them R1 and R2. And the angle at which you come out of the prism, let me call that angle to be angle of emergence. Okay? Angle of emergence E. Then we are interested in deviation, the total deviation. How will that look like? By the way, how do you find deviation of any rays? You make an extension, na? You make an extension. This can be considered like this. Then the ray gets deflected in this direction by angle of deviation delta 1. What about this one? This was going like this, but then it got deflected, and this is the angle of deviation delta 2. Yes. If I extend this back, then what is the final ray and the initial ray direction making? Total angle. Let's call it delta. That is the total deviation. Just by looking at it, can you tell me what is the relationship between delta, delta 1 and delta 2?
Delta equal to delta 1 plus delta 2.
Can you see that?
Yes.
So total deviation, delta is delta 1 plus delta 2. All the equations that I have numbering, they will be important to us later. Please write with me. Acha, what is this angle? This is R1. Na? This angle is R1 and this angle is R2. Can you tell me, is there any relation between delta 1 R1 and I? Delta 1 R1 and I?
I is equal to R1 equal to 2 times delta 2.
2 times.
I equal to delta 1.
I equal to what?
vertically opposite.
Mhm.
I equal to delta 1 plus R1.
I is equal to delta 1 plus R1. Can you see that?
Yes.
This is basically vertically opposite angles. Huh? So then what will be delta 1? That's I minus R1. Equation number 2. Now, can you tell me what is the relation between E delta 2 and R2? E delta 2 and R2? Yes? Any relation? I think this angle is equal to this angle. Yes? What is that angle?
E minus delta.
E minus delta 2. E minus delta 2 is equal to R2. Then what is delta 2? Delta 2 is equal to E minus R2. Is it correct? Please check my equations. Then what will be my total deviation? Then delta will be equal to delta 1 plus delta 2. And this is I plus E minus R1 plus R2. Now understand this, R1 and R2 are angles which I don't want, but rather an angle which I already know by looking at the prism itself. Then are these R1 and R2 related to some other angle? Now look at this thing. Look at this triangle which I am making. So look at this triangle. This was R1. This is R2. This is A. Can you look at this? I am talking about this thing. If this is R1, then what is this angle?
90 minus.
That should be 90 minus, because these dashed lines are basically normals to the surface. Huh? We can make them a little better. So this should be 90 minus R2. What about this one?
90 minus.
90 minus R2. The sum of all angles of a triangle are going to be equal to 180. Then what should be the relation between A and R1, R2?
8 plus 1. A minus R1. Minus R2.
Then A is equal to.
Minus R1 plus R2.
Do you see? And remember that angle of prism is something that the manufacturer actually decides. What angle do you want in the prism? That's a fixed value, huh? For a given prism. That's a fixed value. So R1 and R2, which were basically variables for us, their addition is a fixed value. Then what will the delta become? The delta becomes I plus E minus A. This is another important equation. Yes? Is it okay? Good. Now remember that A is a constant for a given prism. A will be a constant. What does this delta depend on? There are three things that you can see on the RHS. Then you can in general say that delta is a function of I, E and A. But what is the only independent parameter in this RHS? A. A is fixed for a prism, so let's not talk about that. That's a constant.
I.
Why I? Why not E?
Is dependent.
E is dependent on I, but how? How can you say such a statement? That E is dependent on I? Yes? Any answers? Understand this. If I apply Snell's law here, then E gets related to R2. R2 is related to R1. Now, if I apply Snell's law here, then R1 is related to I. So E is basically related to I. E depends on I. So the only independent parameter is what? I is the only independent parameter. So delta depends only on I. So even though there are three terms that you can see here, E, if I write this statement, will you be able to understand this? E is a function of I.
Yes.
And thus delta is only a function of I for a given prism. Obviously from prism to prism A will change, so delta will depend on A, but for a given prism it's only dependent on I. Only dependent on I. Okay? Now let me ask you this. Achha, by the way, you can even find a relation between I and E. So I don't want to go through the whole exercise, but there is, if you keep on applying the Snell's law, you will find a relation between I and E. Okay? I'm not writing it right now, but remind me later, I will give it to you later. Let me ask you this. A question will be, for how many angles, how many incident angles do we find same delta? For how many angle of incidence will I find the same deviation? This is the question. What do you think should the answer should be? Every time I give an angle I, this will delta will change, na?
Yes.
So only one angle I will correspond to one delta. Let's think about this. Let me make a diagram and let's come back to the same question. This is my ray, gets refracted again. This is my normals. And then what is the deviation angle? This is the deviation angle. Yes or no? This is angle I, this is angle E. Is it okay? Angle I, angle E. What if, now let me ask you this. What if I place my source here and such that my rays are just following this direction? Then how will they pass? Do you understand? If my rays are coming like this now, how will they pass? Such that I is equal to E at this point. My I, E becomes I.
Same way.
It will follow the same path. It will follow the same path. And actually, if you were to find the delta for this, then what do you think you will find? What do you think you will find? You will find the same delta. Do you understand? So this is symmetrical in that way, that if I were to give the incident, the light ray on angle I comes out at angle E, but now if I pass the ray at the same angle E, it will come out at angle I and the deviation will be the same. Do you understand why? Because in delta, what is the term? I plus E. I plus E. So अगर मैं I को E से change कर लूँ और E को I से change कर लूँ, will it change? Nothing will happen, right? It will be the same delta. So for how many angles of I do you find the same delta?
2.
You find for 2 angles. Do you understand? Because it's symmetric. It follows the same path. So for 2 angles you find the same. For 2 angles of incidence you find same delta. Does it make sense to you? That it will follow the same path as before. You can take some angles. Let's say यहाँ पे 10 degrees पे भेजा, यहाँ पे it comes out at 50 degrees, and now I place my I as 50 degrees. It will come out at 10 degrees. It will do so because it will follow basically the same path. है ना? Those are crude examples, but hopefully you understand. So now you can already think of a function now, or how the graph will look like. How the graph of delta versus I will look like. What is the nature of the graph? That for 2 values of I you are getting the same delta. Can you tell me what kind of graph it will look like? For 2 values of x-axis you are getting the same y-axis value.
Like a V.
Like a
V.
Any other answers? क्या बोल रहा है? For two values of x-axis, you are getting the same value of y-axis. Can you predict the graph? How will the graph look like?
Like a parabola.
Yes, maybe like a parabola. Does it make sense? So if I make the graph, it's not exactly like a parabola actually. The graph looks like this actually. It's not exactly a parabola. But do you see that for two values of I you are getting the same delta? ये मैं थोड़ा गंदा लग रहा है. Let me make it again so that it will be clear to everyone. Let's say this is delta 1 and for this deviation at this value of I am getting the same deviation. Also at this value of I am getting the same deviation. Yes or no? It cuts the graph at 2 points. That means what will be this angle? This will be the angle of incidence. There is one delta. What will be this angle? Angle of emergence. At 10 degree I am finding the delta and also at 50 degree I am finding the same delta. Are you understanding? Should I repeat it?
No.
So clear? Then do you see a peculiar thing about this graph?
It is increasing.
No, one more thing. At one point, you are finding that there is only one value of delta. What is that point?
The downmost, lowest point.
No, at the start से से यहाँ पे ये हो रहा है.
The bottom.
That's the minimum value of this function. If you look at it, are you finding any two values? Are you understanding that? At this point, look at this point.
Yes.
How many values of x-axis correspond to that delta?
Only one.
Only one, and this I will call as delta minimum. The minimum deviation angle. At this, what should be the condition between I and E? What do you think?
Equal to.
They should be equal. So I is equal to E at this point. What do you think? Yes? So when delta is equal to delta min, when delta is equal to delta min, I is equal to E. And let's call it some I naught. Some I naught. Achha, if you remember, this is R, na? R1, this is R2. If these angles are same, then what about this R1 and R2? What can you comment about them? They should be same as well. If I apply the Snell's law, what do you think? This I naught, this R1 becomes some R naught. This is also I naught, so this R2 becomes also the R naught. So they will be same.
Yeah.
So then R1 is equal to R2 is equal to R naught. Same R. Yes. Then what should be A? A should be 2R naught. And what should be delta? Delta is equal to 2I naught minus 2R. Delta min. I should say delta min. Is there any problem up until now? Are you understanding things? I'm going very slowly today. Delta min is 2I naught minus 2R naught. Okay? By the way, there is a relation between I naught and R naught. Huh? How can I find that relation? By Snell's law? What do you think? If I apply Snell's law here, will I find a relation between I naught and R naught?
Yes.
If I apply Snell's law, then what do I get? By Snell's law, 1 into sine I naught is equal to mu into sine R naught. Yes or no? What about mu? Mu is equal to sine I naught by sine R naught. Is it okay? Achha, by the way, this R naught can be written as A by 2, na? What about I naught? This basically is A. This is A. Let me write it again. This is A. Then what is I naught? I naught is delta min plus A divided by 2. Please check. Then what should be mu? What is the mu that you are getting? Mu is equal to sine of delta min plus A divided by 2 upon sine of A. Have you seen this formula before? This is the mu of prism, by the way. This is the mu of prism. Did you understand?
Yes.
Fairly simple derivation. If you are done with this, then tell me. I have to discuss some notes as well. Acha, remember what is A? What is A? What is it called?
Angle of prism.
What about delta min? The angle of minimum deviation. And what is that mu represent?
Mu of prism.
Mu of the
Mu of prism. It's not the mu of the surrounding medium or anything. It's a prism ka mu. And for now, we are considering the whole piece of prism has the same mu. It's not like half of it is other mu and half. Maybe we will do some questions like that later, but not now. Is it okay? Let me write that stuff. So mu is Ri of prism. What is A? Angle of prism. And what is delta min? Angle of minimum deviation.
Yes.
If you're done with this and tell me, I have to write some notes as well. Please remember all the formulas that I have boxed and all the formulas that I have given numbers. So let me go through that again. Given, okay, I have boxed. These box these equations, huh? Can I write the notes?
Yes.
So, the first note will be, what if your prism is immersed in a liquid? Then what happens? If prism is immersed in a liquid, it's a very simple task. You just have to write instead of 1 that I wrote here, I did not write 1. Instead of 1 I wrote here, you just substitute mu L. That's the mu of the liquid. And then what will be the formula that you get? You'll get something like mu P, that's mu of prism, divided by mu L. And I think it was written something like this. ऐसे लिखा? Please check. Correctly लिखा?
Yes.
This is equal to sine A plus delta min divided by 2 over sine A by 2. Okay. If your angle of incidence is quite small, then what will you get? If I is small, then what can I substitute? Sin I as I, na?
Yes.
So by the way, if I is small, then I will also assume that R is small. Then I will get something like 1 into sin I is equal to mu into sin R1, na? So this can be approximated to I, and this can be approximated to R1. Then I is approximately mu R1 by Snell's law on the first surface. What if I apply the Snell's law on the second surface? What is the relation that I get? Similarly, I will get something like E is approximately mu R2. Yes. Then what was delta? Delta was I plus E minus A, and this is I is mu R1 plus mu R2 minus A, and if I take mu common, R1 plus R2 minus A, but then R1 plus R2 is A, so mu A minus A, I can take A common, and then what will I get?
mu minus
Delta is mu minus 1 into it. That's a direct relation. If your angle is small enough, please remember this as well. Okay. ऊपर का छूट गया. I will wait for a minute, then I will go to the third point. Let's talk about the condition of no emergence. By the way, no emergence meaning what? What will happen?
just passes through without deviation. Total internal reflection. Total approach.
TIR will occur na, somewhere. On the second surface, TIR will occur?
Yeah.
No emergence. So something like this. So let me come back to the diagram. The diagram was something like you have angle I. This is R1, this is R2, this was A, this is E. And what is the relation that you know? That A is equal to R1 plus R2. We want R2 to be something such that this E becomes 90 degree. This E becomes 90 degree. So you have to find some minimum value of R2 for which the TIR will occur on this surface. Okay? So we will try to find that minimum value. By the way, what is the relation between R2 and R1 like this? So R2 is A minus R1. If this guy becomes maximum, then this will become minimum. Yes or no? So R2 mid corresponds to A minus R1 max. And what is this R2 mid? This is a minimum angle for which TIR will occur. Yes, minimum angle for which TIR. But how can I relate the TIR? By the way, this R1 max, what can be the R1 max? I can relate this R1 with I by Snell's law. So what will I get? By Snell's law,
1 into sin I.
this will be 1 into sin I, that's equal to mu into sin R1. Now look at this. This mu is a constant, na? And 1 goes away. If R1 becomes the maximum value, then what should happen with I?
Minimum.
Minimum. If your R1 becomes maximum, that means your RHS has become maximum. That means to become it equal, you have to make I to be maximum as well. Right? The sin I max is equal to mu sin R1 max. But what is the maximum value of I? What is the maximum value of I? That should be 90 degrees, huh? The maximum value is 90 degrees. Then what is the sin R1 max? That's 1 by mu. But what is 1 by mu also equal to? That's sine theta c. You know this? Sine theta c. And theta c is the critical angle for which the TIR occurs. Right? Then what is the relation between R1 max and theta c? R1 max is equal to theta c. Do you understand? If R1 max is theta c, then what is R2 min? That's A minus theta c. R2 min is A minus theta c. This is the thing that we found by this analysis. But what is the common thing that we can expect? What should R2 min follow? R2 min for TIR to occur, R2 min should be at least equal to theta c, maybe even greater than theta c. Only then TIR will occur. So for TIR to occur, for no emergence, what is the condition? That your R2 min should be at least greater than or equal to theta c. It only makes sense, no? But what is R2 min that we found? That is A minus theta c greater than theta c. Then what is A? That is greater than or equal to 2 theta c. And this is called the condition of no emergence. Condition of no emergence. In problems, you should always check if theta c and A is given. Theta c will be given in the form of mu. If mu is given, basically theta c is given. So if mu and A are given, then you should always check, is the condition of no emergence occurring or not? Is it okay with you? There's still some theory about dispersive power and all those things, but we will talk about it in the next lecture. Let's do some problems related to this. So when you're done, then tell me. I have not prepared any sheets because I was lazy. So now I will write the questions on board. Okay. Is there any step that you did not understand? Anybody? Can I write the question? We'll start with simple questions and we'll go to something interesting. So, start with a very simple question. How much time do I have?
35.
I have plenty of time, no? 45 minutes.
55 minutes. And 20.
25 plus 20 is 45. Am I correct? Okay, good. Please remember that we have only talked about homogeneous prisms in the sense that I have talked about only one mu throughout the whole thing. Homogeneous and isotropic actually. attend the question. I'm giving you 3 minutes. I will start at 12:41. Any answers? No. Let me give you some options and then you answer. Option A is correct. Anybody else?
A.
Yes. Should I start or should I wait? Correct. Okay, I'm starting with a question. It's given that you have two surfaces. One of the surface, by the way, refractive angle is 30 degrees. What? That's A, na? Angle of refraction. And what else is there? Yes. You have a prism. Your angle of incidence is given to be 45 degrees. And now one of the surfaces is coated. Let's say this is a coated surface. And then your ray is made incident, it hits the surface in such a way that it retraces its path. That is given in the question. No? So it goes and hits here. Let me make a little better. It's here. Rather, whatever. It's here, then retraces its path. It acts like a mirror, by the way. Acts like a mirror, and for a mirror, at what angle with the surface will you retrace your path?
90 degrees.
At 90 degrees. Then what is the angle you are taking with the normal?
0.
That's 0 degrees. So what is R2? R2 equal to 0 degrees. Then what is the relation between? So they are asking to find a mu, and for mu, what is the relation? If I apply this Snell's law here, then what will I find? 1 into sine 45, that's equal to mu into sine of R1. But I don't know R1, that's why I'm going to find it like this. So A is equal to R1 plus R2, but then this is 0. So what R1 becomes? 30. Then I get my mu very simply. What is mu then? Sine 45 divided by sine 30. Can you tell me the answer? 1 by root 2 divided by 1 by 2. That's root 2. Is it okay? The main line that you have to understand was, as the ray retraces its path, the angle it will make with the normal is 0 degree. So that means the refracting angle is going to, this angle R2 is going to be 0 degree. Then you are done with the question.
Can we apply the condition of no emergence like sine Imax equal to 1 by 2?
I think that condition I told you when there was no coating.
Sir, but still emergence is not zero.
Having a mirror and having a refracting surface where the emergence doesn't occur.
What is the difference?
Like beyond the theta c, it will act basically the same.
So why can't you apply that?
You should be able to.
I mean, we are still getting the right answer, right? Sine Imax is sine 45, 1 by root 2 is equal to 1 by root 2. So mu equal to root 2.
So you got it like that. Okay. Can I start with the next question then? So I'm writing the next question. Again, all simple questions. Okay, let me give you some options. Any answers? I will start in 2 minutes, okay? That's correct. Anybody else? Come on, it's not that hard. Okay then, I'm starting with a question. It's given that delta min is equal to A na? And it's also given that mu is equal to root 3. Then they are asking to find what is delta min, rather what is A. They are asking this now. Then is there a relation between delta min and mu? We are given this to information. What is the relation between delta min and mu? Mu is equal to delta min plus A divided by 2 divided by sine of A by 2, no? Yes. But then this becomes sine of A plus A divided by 2 divided by sine A by 2, and that will basically become root 3, that's equal to sine A by sine A by 2. How do I proceed? How do I find A now? Then sine A divided by sine A by 2. What can I do here?
2 sine A by 2 cos A.
Yes. Apply the half angle formula. That's sine 2 sine A by 2 cos A by 2 divided by sine A by 2, and then what will you get? You will get something like cos A by 2 is root 3 by 2. But then A by 2 is cos inverse of root 3 by 2. What is this angle? That's 30. Then what is A? You're done. Very simple. How many of you got it actually before me? Let me write the next question. Again, this one. will start at 12:56. That's correct. Yes, that's correct. Anybody else? Let me give some options. I got only one answer. Anybody else? But he will not say. Idiot. Take a two answers. Okay then, I'm starting with the question. What is delta का formula? One of the simplest formula is delta is I plus E minus A. And if we look into the formula, we already know two information. Na? A is given, I is given. The only thing that I need to find is E. Then how will I find E? If I know R2, will I be able to find E? By Snell's law. If I know R2, will I be able to find R1? I will find it by A equal to R1 plus R2. If I know R1, how will I find R1 by the way? If I apply Snell's law here. Snell's law here, equation, Snell's law. You will get khatam. Apply Snell's law. Then what will you get? 1 into sine of 45, that's mu. What is mu? Root 2 into sine R1. Then what will you get? I think you will get R1 as 30 degree. Yeah? Once you know R1, will I be able to find R2? So R2 is equal to A minus R1. What is A? That is 75 minus 30 is 45. I found R2. Now that I know R2, will I be able to find E? Very simple again. Mu into sine R2 is 1 into sine E. Now what is this R2? So root 2 into 1 by root 2. Then what is E? And again 90 degrees. Now I am done. What is delta then? Delta is I is 45 plus 90 minus what is this A? 75. Can you tell me the answer of that?
60.
So what is delta then? question, you write it better. You resume this. Let's say you are given a figure like this. What's that done? Let me write the question. And then we will do This is an interesting question. Attempt this one. Let me give you 6 minutes for this, or maybe 5 minutes. Then I will start. Attempt. Should I give you a hint? Before any question, as I said already, you should always check the condition of no emergence. Please check that and then follow up. Okay? That's critical angle. Critical angle of what? DIR पढ़ाया था? Incorrect. Not take into consideration that the third surface may also refract. Just because I have been talking about two surfaces doesn't mean the third will rotate. There is a refraction in third surface as well. Obviously.
Doesn't it leave through?
Obviously it will leave. क्या बोला? Does it lead to AC? गया कुछ नहीं हो Yes, any answers? Incorrect. 1 minute left.
Side head.
Prism 40 degrees.
Incorrect.
239.
Should I start then? Or do you want me to wait? Start. Sure.
So 105 degrees.
Incorrect. Come on, somebody give me a correct answer.
So 90.
Incorrect.
Sanskrit.
70.
Incorrect.
60.
Incorrect. I keep on guessing. Incorrect. 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 Okay then, I have waited long enough. Now I'm starting with the question. Let's start with it. So as I just told you, you should always start with the question if mu and a are given. You should always check the condition of no emergence. And what was the condition? A should be greater than or equal to 2 theta c. But what is
65
it?
degrees.
110. Is this greater than 2 theta c, which is? Actually, what is theta c by the way? I should find theta c first. The sine inverse of. What is this? That's 45. Then what is 2 theta c? 90. But this is always less than a, which is equal to 110. That means what? There will be no emergence. It will reflect. TIR will occur on this surface. So TIR occurs on surface AC. Then what will occur? So let's go step by step. Let's make the diagram. I have this prism. The rays are coming at 45 degrees. Will come here. TIR will occur. If this is angle R2, then this is also angle R2. Yes or no? By laws of reflection. And this is angle R1. It will come here, by the way, this ray will come here with respect to normal. If I take the normal, that's right. The ray को मैं ऐसे पकड़ा. And with respect to normal, it will bend away from the normal. Na? Yes or no? Bends away from the normal at some angle. This is the angle of emergence E. Does it make sense? Now I have to talk about so many angles of this deviation and then add all of them. Now understand this. Let's take this point M, N, Q. And these are, then what will be the deviation at M? For that I have to find this What will be the deviation by this? This will be the deviation, na? This is delta. Rather, not that. But rather, this is the actual rate, so this is delta. है ना? अच्छा, if this is 90 degree, can you see that 90 degree? So if I know R1, will I be able to find delta? That's delta M, to be more precise, delta M point M. तो R1 निकालना पड़ेगा, but how will I find R1? Snell's law. अब बताओ क्या है? At point M, 1 into sine of 45, that's equal to what? Mu. But what is mu? Root 2 into sine of R1. But then what will it become? R1 is 30 degree again. R1 is 30 degree, that means what? What is delta M then? Wait. Arey nahi. This angle should be equal to this angle. So if this is 45, this is 45. That's not 90, I made a mistake. This is not 90. This is 45, this is 45, then what is delta M? This should be 15.
Yep.
Yes. Answer 50. Incorrect.
65.
Incorrect. Still we were getting wrong answers. Very good. AF 20. This is the deviation at point N. So the ray got deviated like this. Huh? Achha, when the ray is going like this, then it gets deviated again in the same direction. Keep a track of in which direction is the deviation occurring as well. Huh? ये किस direction में? This is called clockwise. This is again clockwise. So I should add the deviation. What about this deviation? Anti-clockwise. So I should subtract this deviation. Okay? So now can you tell me what is this? Achha, what should be the deviation? This by this. Enough? By the way, what is R2? R2 and I already found R1. Can I find R2?
Yes.
A is equal to R1 plus R2. Then what is R2 equal to? A minus R1. What is A? 110 minus R1. That's what? 30. So this is 80. So R2 equal to 80. That means what is this angle? 80. Achha, if this is 80 and this is normal, then what should be this angle?
10.
That should be 10. And this should be as well 10 actually. Then what should be the deviation at N? This 10 plus 10?
20.
That should be 20. So delta N is equal to 20. Is it okay? Now there is another deviation at point Q. But in what direction?
Anti-clockwise.
Anti-clockwise. अभी कोई बता सकता है angle of emergence what will that be? Can somebody tell me? What will be this angle?
30 degrees.
30 degrees होना चाहिए? Do you understand how 30 degrees? So that should be 30 degrees. That should be 30 degrees. Then I can apply Snell's law and find E. Then somebody tell me what is the at Q. What will I find?
Root 2 into 1 by 2.
Mu, this root 2 into
1 by 2.
1 by 2 is equal to 1 into sine of E. And then what will I get then? That's 1 by root 2. So E is equal to 45 degree, yeah?
Yes.
If E is equal to 45 degree, then what is the deviation at Q? What is delta Q? अब देखो rays कैसे जा रही थी?
30.
Rays were going like this. It got deviated to this direction. What do you think that angle should be?
45 minutes.
देखो ये ऐसा है, ये 30 है, ये 30 है, and then this is the deviation.
50 degrees.
So it should be what? 50. Are you understanding? Then what is delta Q? 15. Then what is the total deviation? Delta is equal to delta P, delta M plus delta N, and then what should I write?
Minus
Minus
delta.
delta. So 15 plus 20 minus 20, and then you will get 20 degrees as total deviation. Did you understand the question? There were many deviations here, and then a lot of geometry. And I think the diagram is very hideous now, but hopefully you understand. If there is any angle that you did not understand, then please ask. We'll go over the whole solution again. And right. And please state whatever mistake you were doing. At least 10 answers that you gave were incorrect. I knew that. My idiot. Your diagram is incorrect. It will go outwards. So in general, you should remember that as long as your deviation is along the same direction, when I say direction basically clockwise or anti-clockwise, you keep on adding. The moment it switches the direction, you subtract. So it's clockwise, then anti-clockwise, then add, subtract. If it's anti-clockwise, then clockwise, again add and subtract. Is it okay?
Okay, sir.
Right. So please write the solution. Then let me give you a homework question.
First one second
Or rather, we will discuss some things next time. So nothing more for today. Okay.